Very good morning to all of you. I once again welcome you all to this current video lecture. In our last lecture, we started the new chapter from the syllabus, that is the fundamentals of organic chemistry, in which we discuss about the simple introductory part of the chapter as well as the next important point, that is called as the different physical properties of the organic molecules, in which we studied the melting point, boiling point and solubility of the organic molecules. Now today we are going to take the next part from the chapter, that is called as electronic displacement, and in which we are going to take the important concept, that is a functional group of organic molecules and the reactivity of the organic molecules. Now, before taking the definition of this functional group or what is the meaning of this functional group, we know that each and every molecule has the some type of the atoms or groups that may be electron rich in nature or they are electron deficient in nature, or in other words we can say that some of the atoms or groups in a molecule may act as an electrophile or it may have the some type of the nucleophile. So whenever these molecules react with one another, what happens? Not the total molecules take part in a particular chemical reaction, but one important part that actually involves in a chemical reaction, and that important part or that part of a molecule is called as the functional group, and that is nothing but the site of reaction. This part actually take part in a chemical reaction, and that's why we call it as a functional group. So each and every organic molecule has the fixed functional group, and that is an important part for any particular chemical reaction. For example, if I take here a simple example of organic molecule, there is alkene is there, that is ethylene. When this ethylene molecule is reacted with a hydrogen bromide, then we have to look towards what type of the site of reaction is there in these molecules which actually take part in a chemical reaction. So in this ethylene molecule, we know that this carbon-carbon double bond is important because it is called as the functional group of this molecule. It actually take part in a particular chemical reaction. Now what happens if I take 1 mole of this ethylene plus 1 mole of this hydrogen bromide? In this hydrogen bromide, what happens? The partial positive charge is there on this hydrogen and partial negative charge is there on this bromine, because there is a electronegativity difference is there between this hydrogen and bromine. After that, what happens? This ethylene molecule has the pi electrons, or it has one pi bond. We know that this pi bond or pi electrons are loosely bound. They have this is a weaker bond. That's why what happens? This H plus is there. That's the electrophile from this hydrogen bromide. So this pi electron or this pi bond attacks on this H plus. This pi bond or pi electrons attacks on this H plus, and we get the first intermediate product, that is the CH3 single bond. This CH2 is there, CH3 single bond, CH2 is there, and after that what happens? This CH2 becomes positively charged because this double bond converted into this single bond. After that, in the next step, what happens? This bromine from this hydrogen bromide, this now act as a nucleophile, and this nucleophile now attacks on this electron deficient carbon, and finally we get the final product of this reaction, that is CH3 single bond CH2 single bond bromine. So this is nothing but the formation of ethyl bromide from this ethylene by the reaction with hydrogen bromide. So we can say that in this reaction the carbon double bond carbon is called as the actual site of reaction, and that's why it is called as a functional group. Then this molecule reacts with hydrogen bromide and finally we get the ethyl bromide. So in this case what happens? This carbon double bond carbon take parts in a reaction. Now if I take the another example, simple example, for example this is a benzene is there. I take here benzene. Now when this benzene can be reacted with one electrophile, that is a NO2 plus. If I take here NO2 plus, so what happens? Now these two type of the different molecules are there. One is called as this benzene, second is called as this is a nitronium ion. Now, as far as the chemical reaction is concerned, what happens? This benzene consists of this type of the pi bond. 3 pi bond is there, and we know that this pi bond have the 2 pi electrons. That's a total 6 pi electrons is there. That's why these act as a nucleophile, and this NO2 plus is there. It act as a electrophile. This NO2 plus act as a electrophile. So what happens? This carbon double bond, carbon from benzene attacks on this NO2 plus, and in a first step we get here one intermediate compound is obtained. This type of compound is obtained. This is a NO2. This is double bond converted into single bond. So positive charge is created at this carbon. Now we know that initially this benzene is a aromatic in nature, but after the attack on this electrophile can be takes place, it becomes non-aromatic. So to again regain or to again maintain its aromaticity, so what happens in the next step? This removal of this proton can takes place with the donation of these electrons to this adjacent carbon-carbon single bond, and so finally we get here the formation of the final product, that is called as the nitrobenzene formation. This nitrobenzene formation can be takes place, plus H plus can be removed. So in this case, this type of the compound again becomes aromatic in nature. So this is in this reaction what happens? This NO2 plus now act as a electrophile, and this pi bond from this benzene act as a nucleophile. Means one is electron deficient center, second is called as electron rich center. So in this way, this chemical reaction can be takes place to form such a type of the nitrobenzene product. Now, whenever we consider this type of the chemical reactions, we know that each and every chemical reaction involves the reaction between the organic molecules. So from these organic molecules, the functional groups actually take part in the chemical reaction to give the desired product. Now, when we consider these functional groups, and suppose if we take the similar molecules of the same functional group, suppose if I take here the first simple molecule as CH2 double bond CH2, this is the first simple molecule, that is ethylene is there. At the same time, if I take the another molecule from the same family, that is a CH3 single bond CH double bond CH single bond CH3, these two simple molecules I take here for our discussion. What happens? First molecule is called as ethylene, second is called as the 2-butene. Both have the similar type of the functional groups, that is a carbon double bond carbon. Both compounds have the type of the alkene family. Both are alkene compounds. Now we have to check their reaction with a similar reagent. For example, I take here reagent as a HBr. In this case also I take the reagent as a HBr. Now what we have to check here? We have to check the rate of chemical reaction of this ethylene with hydrogen bromide, as well as rate of reaction of this 2-butene with hydrogen bromide. Reagent is the same, just we change the reactant containing the similar type of the functional groups. Now question arises whether the rate of these two chemical reactions are equal or unequal. If it is unequal, what are the reasons for that? If it is equal, what are the reasons for that? Now, if we consider the experimental results, what happens? From these experimental results, it is very clear that this first reaction between this ethylene to that of the hydrogen bromide is called as the slow reaction. This reaction is slow. On the other hand, the second reaction is called as the fast chemical reaction. So this is obtained from the experimental results. Now, when this reaction can takes place between ethylene and hydrogen bromide, we get the product as CH3 single bond CH2 single bond bromine. This ethyl bromide formation can be takes place, and in the second case we get here the compound as CH3 single bond CH single bond bromine single bond CH2 CH3. So in this case, these two type of the products are obtained. First is ethyl bromide and second is called as the 2-bromobutane. But our important point of discussion is that no doubt both these compounds have the similar type of the functional groups, even though with the similar reagents they show the different type of the rate of reaction. First reaction is called as the slow, while second reaction is called as the fast. So this is a one of the point of our discussion. This is a case number first. Now again, if I take the another example for our discussion, suppose if I take the benzene derivative, if I take here benzene derivative, if I take suppose here phenol, if I take here phenol, single bond OH is there, this is a phenol is there. If I react this phenol with a 3 bromine molecules, this 3 bromine molecules, at the same time, if I take the second compound, that second organic benzene derivative as nitrobenzene, if I take here nitrobenzene, again we have to react same compound with the bromine, again we have to react it to the bromine at a room temperature. Then we have to check whether these two compounds show the same rate of a chemical reaction or whether they get differ. So first of all we have to consider their product formation. So whenever this phenol interacts with the 3 bromine molecules, what happens? We get here the tribromo derivative of this phenol. We get here tribromo derivative of this phenol. So this is the first bromine, second bromine is there, and this is a third bromine is there. So in this case we get here 2, 4, 6 tribromophenol. 2, 4, 6 tribromophenol. On the other hand, from this nitrobenzene, we get here the product formation as this is a NO2, and in this case we get here a bromine at this meta position. So in this case we get here meta nitrobromobenzene. This meta nitrobromobenzene is obtained. Now our interest is that whether these two reactions have the similar rate of reaction or different. So from experimental results it is very clear that the first reaction is called as the fast. This first reaction is called as the fast, while this second reaction is called as the slow. First is a fast reaction, second is called as the slow reaction. This is called as the second case. Now if we consider the first case and second case, no doubt in both these cases the compounds are belonging to the same family, even though they get differ their rate of reaction with a similar type of the reagents. So what is the reason? So this type of study is called as the reactivity of molecules. This study is called as the reactivity. This study is called as the reactivity of molecules. This study is a reactivity of molecules. So we can say that no doubt in any chemical reaction, the actual important part which take part in the reaction is called as a functional group. On this functional group, its rate of a reaction is depend. But at the same time, we can say that not the functional group is important for deciding the rate of a chemical reaction, but at the same time, in this case, we have to take some another factors into consideration which also affects the rate of a chemical reaction. Now we are interested to know what are that different factors which affects the rate of a chemical reaction. So that factors are called as the structural effects. That factors are called as the structural effects. Now what is in the structural effects and what are the different type of these type of the effects that you have to study. Now there are 6 type of the different structural effects are there which actually affects the rate of a chemical reaction. The first important effect is a inductive effect. The first important effect is called as the inductive effect. The second important effect is called as your resonance effect. Second important effect is a resonance effect. It may be called as the mesomeric effect. The third important effect which affects this rate of reaction is a steric effect. This is a steric effect is there. The next important effect is called as the hyperconjugation effect. This is a hyperconjugation effect. Hyperconjugation effect is there. Next effect, that is the effect number 5, is there, that is called as the tautomerism. This tautomerism is there. Tautomerism. And the last important effect is called as the hydrogen bonding. Last important effect is called as the hydrogen bonding. Now, these are the 6 important effects. These are the 6 important effects which affects the reactivity of the organic molecules: inductive effect, resonance effect, tautomerism, steric effect, hyperconjugation effect, and hydrogen bonding. So all these effects were to take into consideration while comparing the rate of a chemical reaction, or in a short we can say that in order to consider the reactivity of the organic molecules, these structural effects are very important to judge the rate of a chemical reaction. Now these structural effects we will study in a next lecture with detail. Before that, in today's lecture we started the simple and important point from this chapter, that is the electronic displacement, in which we discuss about the functional group, that is the site of reaction of the organic molecules. For this purpose we take here some simple chemical reactions for our discussion. After that we take into consideration these 2 different cases in which we consider the reactivity of the organic molecules, how this reactivity get differ with the reaction with a similar type of the reagents, and this, after studying this reactivity, what are the different structural effects which affects the reactivity of organic molecules, that we studied in a short. So these 6 different effects are there which affects the rate of a chemical reaction. So with this, today I stop here. The remaining points we will cover in a next video lecture. So with this I stop here. Thank you so much.